Good morning, good afternoon, good evening to everyone. Thank you very much to be here. I know it's a bank holiday in several countries, so this shows a lot of motivation. The session is recorded, and this will be posted on the Knowledge Hub after, just for your information. So I think you have seen that the session is recorded already. Thank you to be here and welcome. This is the Dialogue Series 2023 from GEO. And as you know, we organize this dialogue series about open knowledge. My name is Marie-Françoise Voidreau. I'm a director with the Open Geospatial Consortium with the Innovation Program. And I'm very involved in several activities and projects in Europe, contributing to GEO. I'm a member of the program board and as OGC representative, because OGC is a participating organization. And I'm happy today to be your host. So some house rules to begin with. Please, if you are not speaking, mute your microphone. And if you want to intervene, you can raise your hand under the reaction button and you wait for the moderator to give you the floor. And please enjoy this dialogue series. This is the third dialogue. We have already addressed some of the strategies from the Open Knowledge Statement. I will let Bente introduce that. So today I will be the host. We switch this position, Bente and I, but I will be the host and Bente will present you the Open Knowledge Statement and what is the focus for the current dialogue. So how the open reproducibility research is defined into this statement. Then we will have presentations from speakers who are experienced with this reproducible science and reproducible research. So Pedro Gonçalves, who was addressed that in the context of OGC, will present you that. Felipe Carlos from GEO Secretariat and who is from Brazil. And Paolo Mazzetti from CNR, everyone knows Paolo in the context of GEO. And Gilberto Camara, of course, everyone knows Gilberto Camara in the context of GEO, as he was a previous GEO Secretariat director, but he speaks here with this hat of researcher and scientist. And then this is a dialogue. What the difference between a dialogue and a webinar is that we keep a lot of time to engage with the audience and to be able to address all the questions that we hope the previous presentations will trigger for you. So during the presentations, we will have some polls. Please answer the polls. It's a way to engage with you. It's also a way to support the discussions. So the first speakers will be Bente. She's not here. I will introduce Pedro after. So Bente, I will let you introduce yourself.
Thank you very much, Marie-Françoise. So I will introduce, as you said, a little bit about the GEO Open Knowledge Statement. And I am from Norway. I run a research and consultancy company. But when I was a research director at the Norwegian Mapping Authority, that's when I started to get involved in GEO, since before it was formally formed. And I have had many different tasks and roles in GEO since then. Currently, I am a member of the Data Working Group, and I have the pleasure of working with many of you there. And I was also involved actually in writing, in the writing team of the GEO Open Knowledge Statement. And let's dive into that. We started with, open knowledge has been a concept for a very long time. There are many different definitions of it, understandings of it. And here today we are further developing our definition of it. But to start with, is the Open Knowledge Foundation says simply that open knowledge is any content, information, or data that people are free to use, reuse, and redistribute without any legal, technological, and social restrictions. So many, as I said, many organizations and activists have been working on these principles, proposed what these principles for open knowledge should mean and the methodologies. And what we are doing here now, we are all in the process of further defining what we mean by the principles in GEO. We have the first version of it, I would say, or the principle, the description of the principles are here. A little bit about the story, how this came about. And it was under the leadership of Gilberto Camara here that this was started in 2019. And the discussion first was on open science as part of the strategy for results-oriented GEOs and GEO Knowledge Hub. There was a drafting team, as I said, and it was many members from the Capacity Development Working Group, led by Marcus Canal, and further also worked on by the GEO Data Working Group. Marie-Françoise and I, we are two persons that was part of that process. And why was the importance of open science, particularly to capacity building for the developing countries. It became then, after a series of revisions, the Open Knowledge Statement. And open knowledge is inclusive of open science, but to be more closely aligned with the GEO mission and vision, which aims to support decision-making in general and not only and primarily science. It's the open knowledge that is the wording that we are using, and the statement provides a rationale and an impetus for the open context of activities of the GEO work program and the GEO community at large, which will result then, the results will then be accessible through the GEO Knowledge Hub that we will learn more about later today. So, in short, and we have a list of 11 principles, you might say, and open science, as I said, is included. Open access and citizens and participatory science is included. Open data, of course. Open reproducible research, the topic of today. Open software, infrastructure, hardware, education and evaluation also, and diversity of knowledge. So far in the series, we have covered open science, open access, and open data. Today, we will be discussing open reproducible research. This is a dialogue series where we are covering all of these components or principles, and we are aiming actually to get some open knowledge principles, just as we have for data management principles for GEO. We also want to make open knowledge management principles for GEO. It's the meaning of it in GEO. And the structure is, as you see, we have a dialogue that consists of a theory. So in this case is the principle and some examples. That's the structure. And you see that we have this whole series. The program is here. And the result of this will be an input to the GEO week, the ministerial actually, in this fall. So we are collectively through this dialogue series talking, using the expertise of the community to provide some further advice and perspectives for the GEO week. So the open reproducible research is what we are going to discuss and learn more about today. And the wording in the GEO Open Knowledge Statement is as follows: the programming code or workflow needed to reproduce the analysis analyzing the results, for example, figure, tables, and numbers, in scholarly publications should be released under an open license following the fair and trust principles. I will be bold and add that we might also include the care principles as we have been discussing in previous dialogues, but this is the wording as it is now in the statement. The analysis should be executable and include any environment variables to facilitate understanding, verification, and reuse by others in new context. So it's a description environment, just to say that environment in this context, exactly the context of the variables and not necessarily the nature or environmental data. And that's the introduction to this discussion, this dialogue on open reproducible research. Thank you very much.
Thank you, Bente. So you can see this is very aligned with the GEO spirit, which is about making and sharing data, but not only data, science, research, and capacities. And now the technology enables that with the cloud, the GitHub, the containers. And this is why we are trying to how to make that not only usable, but reusable. And as said in the statement, reusable by others, reusable on other places with other technologies in other contexts. So we will start with Pedro Gonçalves, who has addressed that in the context of OGC, where our innovation program offers international and gathers several partners to address this type of challenge. And the floor is yours, Pedro. So let me introduce Pedro. Pedro is a director with TerraDue, who is very involved in OGC, but of course also in GEO. Is a spin-off from ESA, so very much focusing on Earth observation and focusing also in supporting companies to benefit from the cloud and with Earth observation. Thank you, Pedro.
Thank you very much, all, Bente and Marie-Françoise, for inviting me to this opportunity. So talk about the best practice of reproducible open science. But first of all, we need to, what is the vision, the long-term vision in terms of open science? We want to ensure the reusability and portability of algorithms. And we want also that scientific publications results that need to be reproducible. So we need to be able to reproduce scientific articles, the research, and you need to reuse that research, and you need to be portable in terms of that research. But what is the level of reproducibility we want to achieve? What are the limits there? There is this good diagram that my friend Joshua Lieberman that really tries to divide different types of reproducibility. What we can consider as a rerun. We rerun an algorithm and we have a new job, a new instance. We repeat the execution of some research in a different operator or a different platform. We reuse that research in a different time and space, so applying different parameters, getting new information, or we try to reproduce it in terms of the tools of the algorithms or applying to different scenarios, so in terms of reusing it. So there are different levels of reproducibility, and sometimes the use cases are different, and people we consider at different levels. But we need, and above all, we need a way to uniquely identify what is the data that we are working on, what are the workflows, including the components and the parameters that were used in that research, so that we ensure that Earth observation science is reproducible. And then we need to identify which are the mechanisms and technologies. This is something that we're going to see today that are best suited for different use cases. So it's not a solution that fits all, because you have different targets, you are having different levels of reproducibility you want to aim. So what is this type of information content that you need there? Currently at the OGC, we're talking about Earth observation applications as command line tools that have code behind it, that are in a GitHub or they are already packed. And in fact, they have numerical, textual EU data parameters and are organized as a computational workflow. And what we're using is the OGC application package. It's a common workflow language text document that really describes the inputs, the outputs of that interface, of that application. And this already promoting some views of reproducibility, but a very limited one, in the sense that it promotes the automation, the scalability, reusability of an application, and also portability. The target of this was more concerning that you want to package an application in a way that you are workflow engine neutral, vendor neutral, and you are able to portable your application to different platforms. This is a best practice published by the OGC that defines different viewpoints, in the sense that if you are an application developer, what you need to do; if you are an integrator, so a platform owner, also different viewpoints in what is necessary to achieve this level of reproducibility. But in terms to go a little bit further, in terms of going further to reproducible open science, we have to consider a little bit further down and trying to define what we understand by the different terms. So because we have different cases, we have use cases and actors that are playing different roles here. For example, we have a user that is packaging an application. Alice is packaging an application. She develops an application, she wants to package that application. Now another user might take that application and deploy it into a platform. Could be platform A, B, and C. But then there's another user that executes that service into a platform. And we want to reproduce those results. We want to reproduce on the same platform or in other platforms. So normally when we are discussing, it is something that we need it's a vocabulary that we need also to define, is that we have levels of usability when we deploy and execute. And we have levels of reproducibility, that we are deploying and reproducing, trying to reproduce the same results or trying to obtain with the same parameters. And we go to reproducible applications. So at Earth observation applications, they have pre-processed data, they have fusion data, they have analytic functions, and we need to be able to describe all the steps that was necessary to do a research or a scientific paper, a work and a result that we obtain. In the past OGC testbed 18, we focus on reproducible identifiers for science that target the best practice to trying to get identifiers to describe all those elements that we need into the research. This means identifiers for the input data or the sources of the APIs used or the data cubes used, the application itself, the containers, the corresponding code, but the actual parameterization. So you want to know, I executed these services with these parameters, with this type of data, and what was the result I obtained at that time. At that time in space, I obtained this result. If I go back from 2 years, 5 years now, from now, if I have a different result, why was that? And trying to achieve that reproducibility in terms of the applications. And the idea in the OGC testbed 18 was really trying to use the FAIR data principles and map them to the application. So the goal was really, how do we use the FAIR principles to foster long-term reproducibility of results generated on the platform and associated with publications. There was a side goal here that is important in terms of the platform owners and our side, is that we want to have reliable mechanisms to ensure the scientific impact of a service, of a data processing service, but also of the results. And the work we've done here was to identify the gaps between the applications and the FAIR open science principles. Identify the best practice and identify how we could create identifiers for all the elements: data, services, products, information, software, computing environments. I will not go from this, but we went to findable requirements, accessible requirements, interoperable requirements, reusable requirements. So mapping, taking the concepts from the FAIR data principles, mapping this for the application side. And so going through a development cycle that where the developer implements, as a source control, is building, testing, register the application that it creates in a container, in an application package, and then an execution cycle. Sometimes there are different actors that do this type of things in a sense, but it could be the same actor that is developing the application and is executing there. And so identifying what are the different elements of information we need to achieve reproducibility from the development phase to the execution one. We notice, and it's something that we'll discuss also, I think, in the next hour, there are different levels of reproducibility. This is a very important point, that if and it costs in terms of money and resources. Full reproducibility must consider everything: the algorithm, the inputs, the outputs, all the pans. But you can have different degrees here. That it could be useful just to have a slight strict version. We focus on data processing application services that deal with total solution products, specialized geodata cubes using stack extensions, and we develop an engineering report to guide developers and the platform providers to support full reproducibility for EO data processing algorithms using already exist, so not inventing existing a new standard, but taking advantage of existing specifications and standards like code meta, CWL Prov, and DOIs. What's this? In the sense that we add to the execution phase information like information about the algorithm and giving specific identifiers for the algorithm that we are using with code meta. Code meta is a vocabulary that's standardized in terms of software. It's a minimal metadata schema for scientific software and code that we use to qualify what is our application. It's already been recommended by UNESCO for the UNESCO Software Heritage Project. So it's the idea that you are able to store and archive software for future use. So we are using this vocabulary. And then also in terms of the results, we are using CWL provenance in the sense of how do we achieve reproducibility? How do we store? How do we keep all the results obtained in a given execution? CWL Prov is also a profile, a metadata profile that you are able to store. You're able to do full reproducibility in a sense because you are able to store the resources of an execution, store the research object, and also the workflow execution provenance, how you modeled it, how it was executed, that application. So in the end, you achieve a full reproducible cycle, but you are storing all elements, algorithms, software, and data resources. Now we can drill down and say, no, my economic benefit of storing everything is too much to store everything, so I can drop the data resources. But the idea is that we define the most biggest scenario in terms of guaranteeing full reproducibility, but then we can go down, and we are mapping to the fair data principles. This is a very important point that we are keeping. And the key points is really that we want to have EO research compatible with open science principles, and most important, we want to guarantee long-term reproducibility. And to achieve this, and I think that my colleagues will also discuss it in more detail in the next presentations, we have to enlarge the reproducibility of EO applications outside of a single EO platform boundary. So it's not because I can rerun a code in that platform that I'm achieving reproducibility. I need to be able to, if platform A disappears tomorrow, I need to be able to obtain the same results somewhere else. So I need to enlarge the application or scope outside of a single, avoiding locked in and being portable. Also, a side note, what we understood with all this, even if we were considering more issues as reproducibility, full reproducibility, portability, we understood that also EO application developers can use this as a way to measure how their applications are linked to research, because every research paper will note, oh, I use this data processing service from this platform. And though you can go a little bit deeper in measure the impact of your data processing services. And this is like a carrot you can give to platform for platform owners. So it's something that we need to explore here. And platforms are able to measure and to publicize the scientific impact of their services, not with a fancy leaflet, but with actual numbers, that they can report and what is being used, because you are tracking, you are able to do this full And you need these two last bullets, and I'm ending now. You need these two last bullets because you need to convince several platforms to open up. To open up in the sense that you are able to even if they can have an advantage, to go to platform A and execute my code there. I need to be able to ensure that that code is able to run somewhere else and able to be portable. So thank you very much for your attention. This was a quick, brief and eye-opening for the next presentations. I hope you have good questions and a good session. Thanks.
Thank you very much, Pedro. While you were talking, I have published the link to the test bed and to the research engineering report, because this is one of the benefits of the initiative we run with OGC, is that we always have some open and public engineering reports about the findings that the participants have done during the work. So Felipe works with Geosecretariat. He has a computer science background, and all his personal focus is on processing, visualization, spatiotemporal data, but also on reproducible research. So we have here an expert who decided that the topic is so important that this should be his focus of work. And I'm very happy that we have him here also, because he's working on the capacities from GEO to enable, foster this reproducibility for the benefit of all. So please, Felipe, the floor is yours to present where we are and what you think we can do already.
Okay, so thank you, Marie-Françoise, for the introduction. And as Marie-Françoise said, my name is Felipe Carlos. I'm from the GEO Knowledge Hub team. And today I'm going to share with you some aspects around the GEO Knowledge Hub and also reproducible knowledge. And before starting my presentation, I would say thank you to Bente and Marie-Françoise for inviting me to be here. It's a pleasure to do this presentation. So to start, the first topic I want to share with you today is a little bit about AO application. So as we know, AO applications are used to support a massive variety of activities. And when we are developing AO applications, we usually use various resources, things like satellite imagery, in situ data, tools to process data. We define also workflows to specify the way we are processing the data. We generate results, and based on these results, we produce articles, reports, and so on. And one very important aspect around all those resources is that when we want to create a reproducible application, we need to take care about all the informations around the resources. So for example, when we are working with in situ data, we have from this in situ data informations like metadata with description, licenses, the files, the file description, the content, and also other auxiliary resources like documentation, articles, and so on. And all those elements are very, very important when we want to share our Earth observation application with the community. And we also want to enable the community to reproduce the results we have produced in our application and also reuse in a different context. So when we have this kind of scenario, it's very important to consider that this sharing process must be used integrated approach where we share the application description, the resources, but also the information around the resources that we have. So by doing this kind of thing, we share with the community not only the materials you have used, for example, scripts, data files, and so on. We can also share the context around the application, and this help others to understand why we have defined it or have used a specific tool, the way we configured that tool, and so on. So all of these information are very valuable. And to help us with this kind of sharing process, we have the GEO Knowledge Hub. So the GEO Knowledge Hub is a central cloud-based digital library providing access to Earth observation applications developed by the GEO Work Program activities. And also, the GEO Knowledge Hub is part of the GEO infrastructure and helps GEO to advance open knowledge. And to help us with this sharing process, while we are using the GEO Knowledge Hub, we have a central concept called knowledge package. And this concept will help us to get our AO application and share it with the community. For this, in a knowledge package, we can describe our AO application and also describe and link the resources we have used in that application. So for example, if we have used an in situ data, we can link this resource with in the knowledge package and describe this. The same for the tools we have used, articles and notes, and any other kind of resources we have used or produced in our application. And when we are using a knowledge package, we are able to describe the application using things like metadata, upload files, things, for example, an article describing the methodology, videos describing the application, and so on. Also, we can link this package with external resources, for example, resources that help others to understand the application, and we can also create a DOI and have one unique identifier for the package. So using these features, we are able to describe our application and also empower others to start using the content inside the application and sharing it. And one important point also is that when we are using knowledge packages, we can have multiple versions of it. So when we are, for example, creating an application, we can publish a first version with the initial results, and then while we are evolving the application, we can have multiple versions. And by doing this, we are sharing not only the application and the resources, we are sharing the historical modifications, the history behind the application itself. And also, one important aspect is that all the features I have mentioned for the knowledge package itself, we also have for the resources. So we can create a knowledge package using all the features I mentioned. And when we need to define a resource, for example, an in situ data, we can create and describe this resource inside the package using things like metadata, files, DOIs, and the versioning. So this helps us to organize our application and describe its pieces when we need or following different approaches also. And using that features, we already have users sharing knowledge using the GEO Knowledge Hub. So now we have 105 knowledge packages and 495 resources. And all this content came from 14 different GEO Work Program activities, which includes the Data Working Group, Digital Earth Africa, GeoGlows, and so on. And to show you the variety of the resources available in the GEO Knowledge Hub, we have created this word cloud using the titles of the knowledge packages. And as you can see, we have a lot of subjects like data cubes, agriculture, SEG, and so on. And to use the GEO Knowledge Hub, we provide two main ways to users. So the first one is using a web interface. So users can access this interface and start searching for packages, download data, and so on, and also publishing knowledge packages. But if users want, we also provide a REST API. And all the features that is available in the web interface is also available in the REST API. So users are free to choose the way they will use and interact with the platform. Okay, so now to show you an example in how people are sharing knowledge using the GEO Knowledge Hub and knowledge packages, here I will present an application highlight with using as an example an application from the Digital Earth Africa titled Measuring Crop Health Fusion Digital Earth Africa Data Cube. So to share this application, they have created a knowledge package. So when we create a knowledge package, we have a specific page to the package itself. And here we can have description, files, and so on, as I mentioned. And for each resource, we also have specific pages. And for each page, they provide informations and extra notes around all the resources. And in the resources content, we have things like executable notebooks. We have the results the notebook are producing, and also documentation files. And these documentation files teach us things like computational environments configuration that we need to do to have the environment running to execute the scripts, also a project description providing details in why the project is important, the valuable, the knowledge produced in that project, and also other technical guidelines. And as a final thought, we have that by all those features, the GEO Knowledge Hub helps the organization of the materials from the Earth observation application. So we can create a package, and inside it, we can define the resources, describe each resource individually. And these are kind of things very valuable for reproducible application. As we are not sharing the scripts, for example, we are sharing the script with the context around that script. And this also helps the community to share the required knowledge to understand the application, to start thinking in reproduce the result, but also in reuse that application in a different context to generate the results, applications, and so on. And for the GEO community, this is also very good because we are using the GEO Knowledge Hub, we are creating an index of the community work. So all the work produced by GEO will be available in the GEO Knowledge Hub. So we have a central point where we can access and get the materials and so on from the applications. And this is what I have to share here. Thank you.
Thank you very much, Felipe. I'm super impressed by the progress of the Knowledge Hub, and I hope that Gilberto is happy with the vision he has triggered with the GEO Secretariat, because he's the one who brought this vision to GEO, and he had to fight to clarify the concept. But I think that the implementation shows that, as we say in French, when you think things very clear, you are able to express and do them clearly. And this is what you have done now. So this is great. What we have seen through the two first presentations is that sharing reproducible research is not only making some code, source code available on a GitHub, even if GitHub also gives some capacities to put some documentations around and so on, and tracing the evolutions of the software. But we can see here that you have a full package making consistency and addressing all the different approaches of the research. And this is exactly what we want to talk about today. The next speaker will be Paolo Mazzetti. Paolo works with CNR. He's a researcher with the National Research Council of Italy. He's head of the division of Florence of the Institute of Atmospheric Pollution Research. He's very involved in GEO. He's representing Italy at the program board, and the CNR is coordinating the implementations and evolution of the GEO Discovery and Access Broker. Paolo is also co-chairing the GEO's platform operation team. So you see that he has the perfect background about being a researcher with the university and also knowing very well GEO. Paolo, the floor is yours.
Thank you, Marie-Françoise. Thank you for inviting me to give this presentation. In my short presentation, I would like to introduce some experiences and experiments that we carried out in the context of previous European projects and that we are advancing in this new GEO's Platform Plus project, and that actually addresses some of the many challenges of open reproducible research. First of all, I would like to link back to what you presented before, highlighting that open reproducible research is one of the guidelines suggested for open knowledge, and it is actually, from the description, mostly focused on research practice, although it actually mentions reuse by others in new context. And this is, I would say, the aspect that's of interest for GEO, because GEO is not focused on supporting research practice, but mostly on reusing research outcomes for supporting, let's say, for societal benefit, in particular, supporting decision making, as the GEO statement says, to provide members and participating organizations with the best evidence-based information from Earth observation. And this is perfectly in line with a general framework that we devised and adopted in the ERA Planet project, that was the project supporting and strengthening the European research area on Earth observation, where we tried to capture the problem of bridging the gap between what the decision maker knows about the planet and the policy goals that they have to be compliant with. And the idea is that on the policy side, we need to have the goals expressed with clear targets, and to have a means of verification in terms of indicators and indices. And this is where actually science and technology can support, because through Earth observation and the development of empirical and physical model, we can calculate indicators and indices for the real or simulated situations, so providing the decision makers with information for the best decision. And this is basically what is the research outcome that we need, the development of these workflows and these tools. And of course, there are examples. For example, in the UN SDGs, we have already the policy targets expressed and also set of clear indicators. For example, for the goal on life on land, one of the target is, let's say, combating desertification, and one of the indicators is the proportion of land that is degraded over total land area. And there are activities developing, for example, tools for calculating these indicators. Of course, the problem is that often what is provided is just the value of the indicators and the information that is in some way science-based. But of course, this is not sufficient, and what we have to do is to make this process as transparent as possible. But this means that in, let's say, in the computational era, science-based policymaking should be supported by reliable data and sound scientific models. And this is where actually openness and reproducibility comes into place. And here we have a lot of challenges and, let's say, some opportunities. Of course, from the scientific knowledge, we have the possibility to have many data and many models. But as we know, we still have several weaknesses, mostly related on the lack of documentation or even data and models that are not yet published. And lack of documentation in particular about quality, which is a fundamental information for decision making. But what is important is that even if with an engineering effort, we are able to, let's say, overcome these weaknesses, there will be still some threats for openness and reproducibility. And these are related to, of course, big data challenges, for example, but also large variety in data, but also in software environments adopted. And Gilberto, I think, will elaborate something on that in the next speech. There will still be model complexity, both conceptual and technical. So technical barriers and also legal and financial barriers. For example, running a software could require expensive resources in terms of expensive software, high processing computing, or cloud credits. And there are also some emerging challenges to openness and reproducibility. One is the black box problem with artificial intelligence algorithms, and other is the possibility to have also fake data with artificial intelligence. Anyway, thanks to the digital transformation, we have some opportunities to overcome at least some of these challenges. And one example is with the VLab that we are advancing in the GEOS platform project. It was developed in the course of previous European projects, and it proposed a solution addressing a couple of major challenges to openness and reproducibility. It basically aims at model sharing and running on multiple clouds. It allows modelers to share their open models, whatever software, let's say, they prefer, and application developers to create application using these models and running them on, let's say, any cloud. You can see here the link to the VLab, and also a link to a demo that was presented in Canberra as part of the EuroGeo presentation. The VLab works like this. A model developer can upload his source code on a long-term preservation archive, could be Git, could be Zenodo, with some information on the requirements, something like what Pedro, for example, presented before. And when a user would like to access an application that requires this model, the system just collects the needed resources and package them, including some data or some parameters, and package them in a Docker container. And this Docker container can be sent to, let's say, any Docker compliant cloud where it runs and collecting, for example, data from other infrastructures. And then finally, it provides the result back to the virtual laboratory. So in this way, let's say the virtual laboratory addresses a couple of challenges. One is the variety of software environments through containerization. And the other one is the technical, let's say, model complexity, facilitating access to cloud resources. This is an example that we worked in the past in collaboration with the University of Geneva, and exactly on the SDG indicator 15.3.1, which is the proportion of land degraded respect with the total land. We consider the Trans Earth model, which is provided as a plugin of QGIS and run using some scripts in Google Earth Engine. So this is the situation before. And after, what we did is to bring the code on the virtual laboratory, so making it possible to run on different clouds. We were able to run it using different datasets, but also DataCube from the Switzerland DataCube, and provide results also on different user interface, a dashboard developed by University of Geneva. So we decouple things and make them, let's say, reusable. In particular, the Trans Earth code can be used with different datasets and in different contexts. Shortly, the second challenge that we are addressing is how to document scientific processes. Typically, we may have, for example, let's say, land degradation datasets coming from the virtual laboratory or from a DataCube or from any other tool. And maybe we can know that this was generated, for example, with the trans.earth. But this is not sufficient for documenting things, because first of all, we must inform that this is not just a generic dataset, but that it is a realization of a particular indicator. So we need to explicit this link and to have a policy vocabulary. The same should happen for datasets. For example, we need to know that these datasets used by Trends.Earth are realization of NDVI, soil moisture, and many other parameters. So here we need dedicated vocabularies, and fortunately, there is a lot of work done by the communities in, let's say, define their communities. And we have to make explicit these links to say that Trends.Earth is in general a model that can compute this indicator from this kind of datasets. So basically, this means that we need to have a data base, but also a model base. For example, in GEOs, we can say that we have a database, but we don't have still a model base. And we need also a knowledge base. And we can say that here, the knowledge hub, it can be considered the first core component. What is probably missing is an explicitation and formalization of these links, which could be, for example, done, or let's say started, using community vocabularies and in general shared vocabularies to identify the datasets and models that are part of the workflow. We started actually just a proof of concept in the GEO Essential project at Planet, supporting exactly the workflow on land degradation. We created a small, let's say, knowledge base with all these links, and we created a simple user interface where, let's say, the use of the model could be elevated in a certain sense to a semantic level, so expressing inputs as their content, land productivity, land cover, enabling, for example, semantic search of datasets instead of just a syntactic search of kind of datasets. So to conclude, some, let's say, key message or things to reflect upon. Open reproducible research in GEO should focus, of course, on using research outcomes, maybe particular for decision making, and in general, increasing trust in Earth observation evidence-based decision. Openness and reproducibility poses many challenges, actually. Current technologies provide opportunities to face challenges. Example, the containerization to address software environment heterogeneity, semantic technologies to document the data to knowledge scientific process. We must consider that there are emerging challenges to open and reproducible research. As I said before, black box processing. We have to consider, for example, solution from the so-called explicable artificial intelligence, and also the danger of fake data also coming from the development of artificial intelligence and machine learning tools. And this is all. I put here some links to a couple of papers that we prepared and say something more about the topics I addressed in my talk. Thank you.
Okay, thank you. We go to our last speaker, last but not least, Gilberto. I will not even switch to my screen to introduce you. Everyone knows Gilberto, as I said before, as a previous GEO Secretariat Director, who has triggered all this vision towards open knowledge to upscale the support and the services of GEO to the community, to the global community, moving from sharing data to sharing open knowledge. And here he presents as a researcher, because if he had this vision so clear for him to be able to push it at a very high level, it's because he had a lot of experience himself with that. And this is what he's going to share today. Thank you, Gilberto.
Thank you, Marie-Françoise. Thank you, Bente. Very good to be here and speaking together with Felipe, Pedro Gonçalves, and Paulo. And speaking less gives an opportunity to try to address problems in general. I think the issue which was covered by all speakers is the complexity of the problem we have, in the sense that the opportunity of providing the community with large data sets of open satellite data is a major promise in terms of the outcomes of Earth observation for sustainable development. The other important bit is, of course, the advances, maybe even threatening advances, but let's put it this way, that we cannot fail to recognize that techniques of machine learning have advanced to the mainstream in terms of data handling and data analysis. There are many ways to tackle the problem and to handle the problem, and we saw interesting approaches by Paulo Mazzetti and Pedro Gonçalves, where someone tries to be, let's say, the intermediate between you and the complexity, like VLab tries to do that, and TerraDue also provides ways by which your wish and your needs for the issues are provided by some application that is able to understand and to handle the different compatibilities, which is one option. And I also like to reflect on this fact that there is, let's say, other option besides that, which it's not a question of being better, but being different, is to, I think Paulo Mazzetti referred to it, is the idea that you can develop or write your software based on some support to analyze the data in many ways, by which, for example, a lot of our work on science is based on packages that, for example, analyze statistics for your data and give us indications whether, for example, for health reasons, have we attained certain levels of quality regarding the applicability of vaccines, for example. So I'm going to think of a user who is trying to make sense of the large data platforms. Now, you cannot, I think the starting point for everyone here has to be establish a dialogue with Google Earth Engine. It's important that to recognize that despite the criticism in terms of being monopolist and of course being not transparent with everything, Google Earth Engine provided a template of what could be done with big data. In other words, amassing big data, not provided by Google, but free, provided by others, and then making an API, which it's a very good compromise between simplicity of learning and the complexity of what it can express. So the lesson from Google has been that a lot can be done in their model. Their model is not ideal for many applications, has lots of problems, but still the fact that many people use it and many people are happy with the results they get, give us the sense that people are willing, if you provide them with the right tools, to learn a programming environment, in this case, the Google Earth Engine API, to benefit from the data. So the point here being that people are willing to spend time learning something, as long as they can benefit from it. And for example, in the case of Google, they can reproduce the work. Of course, that reproducibility is limited to Google Earth Engine, and that's not good. You want reproducibility to be done at all levels. And this is where, let's say, some effort would be gone to, and this is ongoing effort. There have been many, let's say, proposals. The OGC has started some work on this, is whether when we recognize that this GEO data cubes or Earth observation data cubes provide an important base for data analysis, one needs to consider, okay, how should I learn the lesson of Google API? what are the lessons? One option, and this is like a different option than the one taken by Paulo and Pedro, is to develop an API similar to the one in Google Earth Engine. This is the software I've been working with, which you say, okay, I have the simplest API I can dream of, not going into details, but that does things, that produces a model, that produces training data, that classifies the data, that produces uncertainty, that does accuracy assessment, and so on and so forth, and which should be the simplest. Simplest is a matter of course taste, but the simplest one for people to learn. The point here, which has to do with some of the problems that we face, and I know that OGC has been working hard on it, is the compatibility between the different data archives. There has been significant advances into the data archives like Amazon, Microsoft, Swiss DataCube, Brazil DataCube, Harmonized Landsat data on adhering to a common standard called STAC. And of course, we hope that the new Copernicus data access service is being built as we speak will also feature very prominently on the STAC access. That is a leveler. STAC is a leveler because it allows you to develop applications that run on different kinds of users. So when you have an API, so this is an approach which is very much inspired by Google Earth Engine, but of course it's not Google Earth Engine. It's something that's open source and runs on any stack ready provider. Is the idea that you have a small number of comments to learn. Could it be in R? Could it be in JavaScript? Could it be in Python? The concept is the same. And that your time by learning them is well, let's say, used because you can do a lot of things. And this is, I'm going to argue that this is important lesson, and I would be far from saying that the API we have been developing in Brazil would be the one API. It's an API. I would, of course, have stated many times that it would be beautiful if a clean, well-defined API would emerge out of OGC effort. Unfortunately, it is not the case yet today that we have it. But the point here is that, for example, this thing that you can do in Google, you could do it, for example, and this is an example of Microsoft Planetary Computing. But since Bente and Marie-Françoise asked me to provide a simple example, I'm going to show a real-life example of a real-life use of an API for big data. It is an effort to classify the Cerrado biome in Brazil. And the Cerrado biome is half of Europe, so 200 million hectares. This is a land use land cover map for 2018 using Landsat and using 50,000 samples and with a convolutional neural network model, reaching 86% accuracy. Okay, so now this is the entire script. It has 1, 2, 3, 4, 5, 6 commands. The first command creates a cube, a database. The second one inputs the data, consisting of the 48,000 samples. The third command trains the data with a convolutional neural network model. The fourth command classifies the data. The fifth command does the smoothing of the probabilities. And the sixth gives you a labeled map. And all the parallel processing, everything remains under the hood, and all the complexities of a convolutional neural network remain under the hood. This is the kind of thing I do imagine, not this one, but variations of it, that will emerge long run as a very nice environment for those that want to use big data. Again, it's not the only option, but it is an option similar to Google Earth Engine, different from VLab, different from Terra2, which they have, of course, much more complex users. But I'm going to argue this is one approach to interoperability, a clean API that you can do in many ways. And I hope that that experience might motivate OGC and the GEO users to actually consider the advantages of that approach to obtain reproducible examples. So in this case, a fully reproducible example of a classification of a large area.
Well, thank you, Gilberto, for your presentation and for emphasizing the importance of standards for reproducible research. Standards have been mentioned, I think, in most of the presentations, if not as much as Nance as in your presentation, but they were present in the slides. I think that this is why OGC is working on that. Considering your wish about progress from OGC on some topics, we need pioneers, we build on the work of pioneers, we just need the community to push, to review what is submitted to become a real standard, because in the process, we have to review and to make it public and to integrate the comments, but we are open to all that. If something is lacking, there is no problem. So we will look at what you have presented here and see if there is some community to push it to become a standard. The care principles are about the sovereignty over the data and what is done with the data for the indigenous populations. So you can compare that somehow with the GDPR and the personal data, but it's related not to one person, but to a community, in this case, the indigenous populations, but it could be extended to other type of communities.
Yes.
So these communities want to know which are the data which are collected related to the community, what is done with the data, with this data, and make sure that this data and knowledge which is built is accessible and can be controlled by themselves. And reproducibility, of course, is important because we have mentioned after the presentation from Paolo that for the artificial intelligence, we need to be able to check the results and the data which have been used. And this is exactly the case also for care, I think.
And you need to be careful as far as putting in the subsequent step, because all the discussions we are having for reproducibility could in fact be a negative. It would be a negative in fact into the care, because we say with the excuse of reproducibility, we take out that control of the data by their own creations. So reproducibility can be an excuse not to execute care, you know. So we need to really take this in consideration as an important topic, because with the excuse of future reproducibility or usability, you can say, okay, now I take your data and I'll take care of it and I host it there because of reproducibility, and it's tricky. So it's tricky to put it, because if we look at it at the same time, they might be cancel each other. So it's something that we need to carefully analyze.
Felipe or other speakers?
Well, I think that the issue has to do with how much control over your data do you need, or can you legally exert? and how much control you need to pass on to your data to third parties. So if you want a very, very strict application of the CARE principles, it means that the processing for certain kinds of analysis has to be done under the control of the, let's say, the community which is involved. In other words, you would have to have data coming from external sources such as satellites, but maybe some input data which comes from field work, which comes from local knowledge, remains under your control. I'm talking about CARE. But in this case, it is obviously the most appropriate practice is the one where the community do their own analysis. I mean, we've seen it in, let's say, in more analog ways, but for example, during this Bolsonaro government, there was a meeting between Chief Raoni, which is a very traditional chief of Brazilian native pre-Columbian populations, and Monsieur Macron, the President Macron from France. And what Raoni brought to the meeting were like lots of sheets of images, and he put it on the table and saying, look what's happening here, here, and here. Obviously, these images have been pre-analyzed by his team and his people before presenting them to Macron, in which case he had understanding of the rights that his population had that were being violated. Of course, this is in an analog way, but nothing impedes in principle that kind of work to be done digitally through new methods. But it's typically that you assure yourself that certain rights, you exercise these rights, and then you go after fighting for them. And using data allows you to support your claims, your rights, your quest for justice in a way that, let's say, gives you more force in the political dialogue.
Yeah, so in the case in the GEO Knowledge Hub, our goal is to have always things open, but when it's not possible, and we already discussed this a lot, our goal is to, okay, you are using a data that cannot be uploaded or cannot be shared. You can create a knowledge resource inside the package that describe that data set, but don't have the data set itself or provide information in how others can access that data set. And for other cases, for example, if user want to upload the data into the GEO Knowledge Hub, or users can do that and private the resource. So other users will see, okay, that package have private resources, and the resources will not be accessed. So this is the approach we are using now. So in our goal with this is, okay, you can upload to avoid you lost this data, for example, or something like this. So you can upload and private it.
Yeah, I think the idea is really as open as possible, as restricted as needed, and this can change in time, of course. So I think we all agree on that, and this applies to data, and this applies also to knowledge, because knowledge is a collection, is a package of data, software, information, documentation, and I think GEO works for the good of the humankind, and the humankind, the good sharing is going in this direction. Sometimes closing has to be done.
I'd like to say my words regarding this issue of not sharing data. Okay, we have seen that many circumstances where data because of conflicts and because of essentially because disputes over power should not be shared. But I'm going to argue there are situations where there is no excuse for sharing things. It does have to do with any sort of scientific purposes. In other words, if let's say the work is presented to the scientific community in terms of published in a journal or in a conference, which means as a means for distribution and improvement of knowledge global, I don't see any reasonable excuse for not sharing the data and not sharing the software, because that is the basis of the scientific, let's say, method, being able to reproduce what you do. So if this reproducibility is not there, I am afraid that science will suffer. And this is perhaps a clear state that, of course, indigenous rights need to be respected, and when they are endangered, they should be protected. But nothing protects those that don't share their paper or the data on their paper, which I think it's now very not a position that we should acknowledge as acceptable.
There is a clear need of transparency. In the last years, science have been criticized a lot or put like demystified, but at the same time, decredibilized. I don't know if it's an English word. And so
Right.
there is a need of transparency, and reproducibility is very important in this.
Right.
But you have the time factor that could help here. That will actually make it possible to do what you suggest, or Gilberto, if you just, with a minimum time delay. So in some cases, it will be reproducible. You will share the data, everything, but you just do it with a slight time delay. But as you say, when it's published, when you publish something, yeah, then it's, I agree. It's in the spirit of research and science that this then should be, we should be able to control it. I mean, the peer review should be as thorough as to check exactly everything, right? So that's the nature.
Yeah, there is one question, one topic I was thinking to discuss with the data working group, but maybe you have some idea about that, is what is the minimum package? Because Felipe has presented this notion of package where you can have software, documentation, peer review papers, and so on. Is there a definition of a minimum package that really makes the package reproducible?
Yeah.
And I don't know if this exists. If not, my idea was maybe to use the packages which are already into the Knowledge Hub to identify what is the most common package, and if there a minimum content of the packages to be interesting, but maybe not reusable, but interesting, and a minimum to really be reusable, and an ideal content of package. So this at the end would give you in the Knowledge Hub packages which are 5 stars, 3 stars, 1 star. Do you understand what I mean?
If I can answer, sorry, Felipe.
Please go ahead.
I think this is related to the level of reproducibility that you would like to have. I mean, if you want just to reproduce the same use case, probably just a minimum information is sufficient, just to know which data and which software was used for generating the product. But if you want to go beyond, in particular to reuse this in a more general context, for example, an environmental model to be coupled with a socioeconomic model for decision making, you have to provide a lot of information more on semantics, for example, to know exactly which kind of data the model needs, for example, but also the pragmatic level, which means information related to the context where that model can be used. For example, you may have, I don't know, a model measuring sea surface temperature, but you may have a model that calculates sea surface temperature for climate climatology, and others that measure for nowcasting. That's completely different. We can imagine that this could be translated in technical information like resolution, temporal and spatial coverage and things like that. But we are thinking this in the GEO Platform Plus project and other projects, but it's, I would say, a very complex topic. And I think we should have this different level of information for different level of reproducibility.
Or starting what I was trying to propose, starting calling differently in the sense of what is reusability or what is reproducibility. Yeah. If we start ourselves using the correct vocabulary, because even we do it all, we call it reproducibility when it sometimes is you are reusing the same model to a different area. And this, when you enter into the AI models, is even worse because you have lots of data. Sometimes what happens in Europe to train your model, but then you try to apply it elsewhere. Can you really do it? And how do you convey this information or convey this metadata that this model was trained only in this area? And so it's quite important to put names, to divide what we call reproducibility now, divide it into different boxes and tackle those issues separately.
Yeah, well, thinking about that if we clarify this vocabulary, probably we have some packages which are reusable but not reproducible and so on. And we might have to clarify that, because I'm dreaming of a period of time in some years from now where we will have thousands of packages into the Knowledge Hub. And as a user, I come and want to select a package, and maybe I will just look for one which is reusable but has a lot of peer reviews. Or maybe I will accept one which has less peer reviews, but which is reproducible because this is my need. And this can drive the selection, I think.
And sorry.
No, please.
And also accept different levels of reproducibility. Even though in the sense of reproducibility, we might have full reproducibility for me is that where you froze everything, you froze the data input, you froze the model, you froze the outputs, and you are able to validate what's happening. But you can just say, okay, I use this data, that is the metadata link, you have an index, you have a link to what was your input data. You are not freezing it somewhere in a cold storage. But then you risk that probably ESA or NASA reprocess that data, and then the Sentinel-2 is no longer the same, even if it has the same name. It is because they have reprocessed it and they discovered a bug, and the data might be different. So you have stars. Also in after OTC testbed 18, the discussion with Josh and discussion with lots of people, we might need to have a classification like a 5-star reproducibility. I put it on the freezer. Cool. 4-star, you have by reference the inputs, for example. So we're trying to think of this, but then we got to the point, and that was also the work that Josh, that figure I mentioned in my first slide of different rerunning or reportability and so on. So trying that we don't use the word reproducibility for all these use cases, but use it differently. Portability is when I want to bring my code and do it in another platform. My script in Synergize, I want to apply it in Google Earth Engine. How do I do it? Is it portable or not? But you might obtain different results. And reuse in different areas, reuse the same algorithm, but in different time and space. So trying to define this vocabulary will help us a lot. I think it's the first task that I will recommend is define the vocabulary so we don't end up always using reproducibility as a catch-all sentence that kills or